Yeah, good evening everyone. I hope audio video is okay. Is audio video okay? Check one time, audio video okay or not? Good evening everyone. Call everyone. I am giving some time to students so that they don't miss anything. But interesting thing is students are giving some time to me. Right? I shown some kindness. I given some time to student so that they don't miss anything. But they are giving some time to me so that right, I will relax. I don't know, still people not came. I shown some kindness, they are showing more kindness. I thought me only having kindness, I only having kindness, I thought like this. But my students are having more kindness, they have more kindness. Yeah, true. I thought I only having kindness. My students are having kindness square. Yeah, in my mind, class is 7:15. That is the reason I'm saying Bhaiya. That is the reason I'm saying. I thought I have only kindness K, but my students are having kindness K square. Yeah, I think this is the time to remind all the people. Right, that is the reason, right? Fine. Chalo, can we start now? Good evening everyone. Can we start? Yeah, let's start now. Everything is ready. Let's start now. Compiler design lecture 3. Compiler design lecture 3. I think 2 lectures are right. Properly edited 2 lectures kept in EPT app. In EPT application, 2 lectures are kept. If anyone having any doubt, you can see that. If anyone having any doubt, you can see that. Properly edited, they kept inside the EPT application. Let's go to lecture number 3. So I'm starting now. Yeah, so one new batch is started with the compiler design. Those people who are serious about GATE examination, they can join happily in this batch. In this batch, happily you can join. You can join GATE CSE or GATE DA, GATE CSE plus DSA, GATE CSE plus right DA, right, GATE CSE plus GATE DA. So you can take whatever possibility you want. Go to ExamPrepTool.com. You have all options. You can select whatever course you like. There is a 25% discount also going on. You can happily utilize it. Next one, EPT, right? In the EPT Telegram group, right? There are daily quizzes are there. Please utilize that. Every day, 2 quizzes are there. Morning 1 quiz, evening 1 quiz. There are 2 quizzes are there. Please utilize this. Next one, EPT 30 days DSA challenge. Every day 1 DSA problem with the algorithm or program. Every day 1 DSA, right? 1 DSA problem with algorithm, if possible, program, right? So please utilize this also. This is also free on YouTube channel. You will find out it. Next one, if you want to be good in DSA, you can join the DSA course, or you can go for right. So right, app development with DSA, or web development with DSA, or only DSA. You can select whatever you want. Now let's come to today's class, lecture number 3. Can you say the date? Can you say the date? I think today is 23. Yeah, 23/07/24. Yes, after 2 or 3 days. Right, after 2 or 3 days, Sai, after 2 or 3 days, it will start. third lecture, I think fourth, fifth, 5 lectures in the YouTube. Remaining all will be there in the right EPT platform. Right, 5 lectures. The third one, fourth one, fifth one will be in the YouTube. Remaining will be there in the EPT application. Yeah, let's concentrate here. Let's concentrate. Everyone concentrate here. Everyone concentrate here. 23rd 07/24. It is a today's class. Let me start. Everyone. Everyone listen. Everyone listen. Lexical analyzer first. Syntax analyzer next. Semantic analyzer next. Intermediate code generator next. Code optimization is next. Target code generator is next. These are 6 phases of compiler or 6 functions of compiler. Lexical, syntax, semantic, intermediate code generator, code optimization, target code generator. Now remember everyone know everyone having some functionality. So if anyone asks you what lexical will do, it will do tokens. What syntax will do, it will create the parse tree. What semantic will do, it will do something related to type checking, like undeclared variable, multiple declaration, right? Something like that. Intermediate code generator, it will create intermediate code. Code optimization, if any optimization is possible, it will do. Next one, target code generator. So it will convert whatever code is available. And after code optimization is over, whatever code is available, it will convert it into target code generation, means final requirement. It will convert into final goal. Everyone know this, right? Everyone know. Now observe clearly here. Listen, observe here. Careful everyone. Lexical analyzer to intermediate code generator. This is called front end of the compiler. This is called front end of the compiler. This is called front end of the compiler. Only last phase of the compiler, which is called back end of the compiler. It is called back end of the compiler. Lexical to intermediate code generation is called front end of the compiler. Target code generator is known as back end of the compiler. Remember, code optimization is optional phase of the compiler. It is the optional phase of the compiler. Means, right? Sometimes code optimization may not be possible. Some people are saying that, sir, why code optimization not possible? While doing intermediate code itself, you may do code optimization. While doing intermediate code itself, you may do code optimization. Means whenever I am writing intermediate code, I may be careful. I may write the code optimization. Means optimized code I may create. It is something like this one. When you are creating a minimal DFA, one way is create DFA, do minimization. That is the one way. What some people will do is, sometimes they may create the minimal DFA directly. Right? Sometimes, if possible by me, I may create minimal DFA directly. Sometimes if I have doubt, I will create DFA. Afterwards, I will do minimization algorithm. So what I mean to say is, while writing intermediate code itself, if I am careful, there is no need of code optimization. Suppose if I have doubt, I will write intermediate code, then afterwards code optimization I will apply. Code optimization is optional phase of the compiler. Lexical to intermediate code is the front end of the compiler. Target code generation is the back end of the compiler. So this is also called as only this if you take. Right? In some books I see this is only this if you see. This is the middle end of the compiler, not front end, back end. It is the middle end of the compiler. It is the middle end of the compiler. It is the middle end of the compiler. So they will ask you in the examination. In the examination, they will ask you which is the middle end of the compiler, code optimization. Which is the optional phase of the compiler, code optimization. Who are the part of the front end, lexical to intermediate code? Who is the part of the back end, target code generation? Target code generation. I hope everyone is comfortable. Some people are asking, your goal is low level, your goal is high level to low level. Your goal is high level to low level. Why are you doing intermediate code? It is always better. Go slowly. If you want to go from right side to left side, don't go directly. And those people who are watching, right? See, those people who are watching this class, can you help me, right? On national highway, when the accidents will happen, can anyone guess? You may see on the national highway, some accidents are going on. Can anyone guess, whoever watching this class, why those accidents are happening? Can anyone help me? On national highway, you may see in the newspaper or you may see in the TV channels, some accidents are happening. What will be the reason? What will be the reason on the national highway? One reason is fast. One reason is fast, that is okay. One more reason is fast, listen, fast left turn, fast right turn. If you go immediately left, immediately right, problem will come. There are some people who are crossing, who are going from right to left immediately. Right to left, they are going immediately. Left to right, they are going immediately. You cannot do like that in life also. You remember, you cannot go right one place to another place directly. Go slowly. Go slowly. Right? Don't jump here and there. If you jump here and there, problems will come. Left to right, you are going directly. Left to right, if you want to go via middle. Don't go left to right directly. Left to middle to right. So high level to low level, go via middle level. Go via middle level. Please careful. Someone is saying sleeping. Yeah, directly going left to right. See, sudden turns in life also, sudden turns if you do, problems will come. Please observe, whoever listening this class, don't do anything blindly. Don't take any turn blindly. I don't like gate, I will write cat. It's not like that. If you don't like gate, take some time. What exactly you want to do that. Don't take blindly. Right? Don't take blindly. If you do blind turns, it will give a lot of bad things. It will spoil your life. Right? So please careful. That's what I want to say from this diagram. Right? High level to low level, go via middle level. Front end, back end. So from now onwards, if anyone asks you what is the front end of the compiler, lexical to intermediate code. What is the back end target code? What is the middle end code optimization? What is the optional phase of the compiler code optimization? Okay, fine. That is fine. Now listen. Everyone listen. Everyone listen. See this correctly. If you see the intermediate code, you will find out like this. See this one. If you see intermediate code, you will see like this one. T1 is equal to A plus B. T1 is equal to A plus B. T2 is equal to T1 star C. Something like that. Intermediate code, if you see, T1 is equal to A plus B. T2 is equal to T1 into C. But if you see the target code, you will see mul R1, R2, or maybe add. If you want, you can keep add. First add R3, R4, something like this. Right? Target code contains something like this. Intermediate code contains something like this. So can you help me? Front end and back end. Who will give machine dependent code? Front end and back end. Who will give machine dependent code? Whenever you are doing compiler, whenever you are doing compilation, front end followed by back end. Okay. Front end, back end, who will give machine dependent code? Front end, back end, who will give machine dependent code? So remember, these are the machine instructions. Machine means processor. These are processor instructions. Remember, it is going to be machine dependent code. It is a machine dependent code. Remember, it is a machine independent code. Front end of the compiler will give machine independent code. Back end of the compiler will give machine dependent code. Someone is saying that, sir, can I ask one general doubt related to college admission? So can you ask us? Can you WhatsApp me? It is a seriously one class is going on. Seriously, one class is going on. Can you ask me? Can you ask me if you have our WhatsApp number? You can you ask me? This is our WhatsApp number. You can ask me. Yeah, fine, perfect, perfect. Come here now. So front end of the compiler will produce machine independent code. Back end of the compiler will produce machine dependent code. Right? I think until now everyone is comfortable. Now see this. Now see this. Everyone listen. Everyone listen. Everyone listen. If I do careful, if I do, what is the meaning of machine dependent code is? Machine dependent code means, listen, machine dependent code means in which machine, in which computer, careful everyone, machine dependent code means in which computer you done the compilation, in which computer you done the compilation, right? The final answer, whatever is coming is that processor, that computer contain which processor, those processor instructions you will see. Machine dependent code means in which computer you done the compilation, that computer contain which processor, that processor instruction set will come. Every processor having instruction set. P4 Pentium 4 processor having one instruction set. Intel 7 i7 having one more instruction set. One processor to another processor instruction set, right? Instruction set is keep on changing, right? Sometimes, right, one processor instruction set is smaller, which is also called as RISC, reduced instruction set computer, right? Some processors instruction set is bigger, complex instruction set computer, Cisco, RISC and Cisco, like that. What I mean to say is, in which everyone listen, in which computer you done the compilation, that computer contain which processor, that instruction set will come. That is the reason it is called machine dependent code. Machine dependent code. Now come to one small story here. Come to one small story. If you do Java compilation, listen, if you do Java compilation, everyone observe. If you do Java compilation, lexical analyzer will execute. Lexical analyzer, right? Whenever you do Java program compilation, lexical analyzer, right? First complete. Syntax will complete. Semantic also will complete. Intermediate code generation also will complete. Remember, Java compilation until here. Right? Java compilation until here. Supposition that in some computer, Java program you compile. When you do Java compilation don't produce low level code. Java compilation will produce intermediate code, which is also called as machine independent code. Java compilation will produce machine independent code. It is a Java program, right? Java program, if you do Java compilation, you don't get the machine dependent code. You will get the machine independent code, because until here it will be done. Now on this one, right? On this machine independent code, right? If you do runtime on this code optimization will be done. Afterwards, target code generation will be done. Afterwards, running will be done. This is the way, right? Java program running will be done. When you say running time, the story will be done. When you say run, remaining story will be done. Java compilation will produce machine independent code. But when you say Java program running, then remaining story will be executed. Code optimization will be done. Target code will be done. Next one is lastly running will be done. But if you see the C program, if you see the C compilation, lexical analyzer will be done, syntax analyzer will be done, semantic analyzer will be done, intermediate code generation will be done. Next one is going to be, right, code optimization will be done. Next one is target code generation will be done. This is the C program. This is the C program. C program, right? So supposedly in some computer, C program you compiled. The output, whatever you will get, is the machine dependent code. Machine dependent code you will get. The interesting thing is C program, in which computer you done the compilation. In that computer only you can run. In the same kind of system, in the same kind of processor only you can run. You cannot run in some other system. In the same system you have to run. So that is the meaning of machine dependent code. The meaning of machine dependent code is, right, that instruction set whichever is coming, only that system can understand. Other systems may not understand. So C program, if you compile, you will get the machine dependent code. That means in that system only you have to run. C program you cannot compile in one system, you cannot run in another system. But in the case of Java program, you can compile in one system, in another computer you can run. You can run in another system. Right? Computer C1 you run the compilation, computer C2 you can do running, computer C3 you can do running, computer C4 you can do running, computer C5 you can do running. That's the meaning of machine independent code. But in the case of the C programming, right, computer C1 you done the compilation, right, computer C1 only how to run. That is the meaning of machine dependent code. So the advantage with the Java program is, in one computer you can do compilation, in another computer you can run. But in the case of the C programming, in which computer you done the compilation, in the same computer you have to do run. So that is the advantage with the Java programming is, right, portability. Portability means, right, in one system you can compile, in another system you can run. Java program having this capability, that is portability. That is portability. Right? In one system compiling, in another system running. But in the case of the C programming, in one computer you can compile, in another computer you can run. No, same computer you have to run. Someone is saying how online compiler runs. How online compiler? Maybe they are doing for user convenience. For user convenience, they may be doing everything by themselves. Right? They may be doing everything by themselves. User convenience is important, so they may be doing everything by themselves. With one click, maybe many things are happening. Is it okay? So here no portability. Because machine dependent code. Whenever machine independent code, portability will come. Someone is saying virtual machine, right? Portability, another name is virtual machine. Means in one system you can run, one system you can compile, in another system you can run. Now, one more important question I want to ask everyone. Java compilation will give high level or low level or right, intermediate code. Java compilation will give high level or low level or intermediate code. Java compilation will give high level or low level or intermediate code. Intermediate code. That is the reason Java got the capability of portability. That is the reason Java got the capability of portability. Right? I hope everyone is fine. So Java program compilation output is going to machine independent code, which is also called as right, right, intermediate code you can say, machine independent code you can say. Right? The advantage is in the different system you can run. The problem with the C compiler is it will give machine dependent code. In the same kind of system only you can run. Right? Please take care. Now it's an interesting question. Everyone observe. It is an interesting question. C compilation, Java compilation. Which one is taking more time? C compilation, Java compilation. Which is taking more time? C compilation, Java compilation. Which will take more time? Go ahead. C compilation, Java compilation. Which will take more time? C compilation, Java compilation. Which will take more time? C compilation, because when you say C compilation, this much should be done. 6 people should run. When I say C compilation, 6 pages should run. But when you say Java compilation, only 4 pages. Only 4 pages. So C, right? Java compilation will take less time, but C compilation will take more time. Java compilation will take less time. C compilation will take more time because C compilation means 6 people should run. Java compilation means only 4 people should run. Next one. C program running, Java program running. C program running, Java program running. Can you say which will take more time? C program running, Java program running, which will take more time? C program running, Java program running, which will take more time? C program running, Java program running, which is taking more time? Yeah. In the case of the Java program running, in the program, when you say Java program running, then it will go to code optimization, then it will go to target code generation, lastly running. So in the remaining phases of the compilation will be done. So left out compilation plus running. Left out compilation plus running. But if you go to the C program compilation, see, C program compilation already done, directly running only. So C program running will take less time. Java program running will take more time because little more, right? Little more compilation left out. Java program compilation will take less time, running will be more. But C programming compilation more, running will be less because C program running means directly running. But Java program running means left out compilation plus running. So please take care. Please, everything is important. Everything as a computer science student, you should take care about what is compilation. In the compilation, how many people will participate? In every compiler is similar way, or different compiler different, right? Different compiler different. The person who invented the programming, he will decide everything. What to keep in the front end, what to keep in the back end, everything he will decide. The person who created the programming language, he will decide what kind of compiler he is expecting because he only will create. See, writing programming language is not a big deal. Writing compiler is a big deal. When he is writing compiler, he will decide what to keep inside, what to keep at the time of compiler, what to keep at the time of running. He will decide everything. So please take care everything. They may ask you what, right? Who are part of front end? Who are part of back end? What is the middle end? What is the optional phase? Next one. Java compilation. Java compilation is a full compilation or right? Half compilation. What is the advantage you will get? If you do half compilation, what advantage you will get? If you do half compilation, you will get portability. What is the side effect? Running time is more, compile time is less. If you do full compilation, what is the advantage? Directly you can run, running time is less, but compile time is more. Everything having some advantage, some drawback. Everything, you cannot get all advantages only. You cannot get all drawbacks only. Everything having some positive, some negative. Yeah, please write down. Everything, whatever you feel, every point is required. Through experience, everything, whatever I am teaching, somewhere in one of the previous paper it is there. See, in the previous paper it is not there, I don't teach. Because as I mentioned to you, compiler book contain 1500 pages. Compiler book contain 1500 pages. If I don't have experience, I will teach every page. Every page I will teach. Because of I have experience, whichever needed, those only I will say. Whichever needed, those only I will say. I can say what is there, right? Reading and saying what is so great in that. I can read all 1500 pages. I will say everything as it is. But the number of marks which are coming is 6 marks. Why you study 1500 pages? What is needed for the examination? Please study that. So I don't say unnecessarily more. Whatever necessary, I will keep in your notes. Yeah, I hope everything is fine. If you okay, I can go to the next one. full compilation C language, half compilation Java. Advantage with the half compilation, less compile time. Drawback, more running time. Full compilation advantage, right? Running time less, but compile time means more, right? Perfect. If you okay, I can move to the next one. Now, if you okay, I can move to the next one. Can you see this also? Can you see this also? Everyone observe. Can you see this also? Can you see this also? One more interesting story is there. Can you observe this also? Richa is saying, good evening, son. Good evening, Richa. Someone is saying, class fee is too much. Okay, fine. Thank you. Thank you so much. Thanks for your feedback. Right? So there is a 25% discount. You can use it. Right? 25% discount is there. Right? If possible, you can utilize it. Right? Thank you so much for your feedback. Now class is going on. Thanks for you. Thanks for you. So now can you come to the next one? Can you come to the next one? Everyone listen. Everyone listen. Everyone listen. One important point is coming. Everyone listen. See this? See correctly? Whenever you say compile, whenever you say program is compiling, remember program compiling means these all people, see, these all people having code. Lexical analyzer having, right, 2 lakh lines of code. Syntax analyzer is having 5 lakh lines of code. Next one, semantic analyzer is having, right, 2 more lakhs of code. 2 more lakhs of code, like that all. Target code generator is having maybe 1 lakh lines of code. So if you add approximately if you add, let us assume 15 lakh lines of code. Whenever you say compile, everyone know compiler is a software. Everyone know compiler is a software. So when you say compile, which is a software, 15, right, this one, 15 lakhs of code. 15, right, everyone know 15 lakhs of lines of code, right, is running. Compilation is going on means 15 lakh lines of code is running. When you say 15 lakh lines of code is running, when you say that 15 lakh, right, 15 lakh lines of code will be present in main memory. This much code should be present in the main memory. Whichever is running, right, that should be there in the main memory. Remember, compiler is a software. Compilation is going on, means that software is running. Whenever you say that software is running, means that software should be there in the main memory. So try to understand it. Try to understand this particular story. Compilation is going on means compiler code is running. Compiler code is almost like 15 lakh lines of code. Right? 15 lakh lines of code should be there in the main memory. Let us assume that main memory is very small. Assume main memory is small memory. Assume that small memory. Main memory is very small memory. Let us assume. So 15 lakh lines of code may not present in the main memory at a time. It is not possible. If possible, if main memory is the bigger one, total compilation code should go to main memory. From there, compilation is going on. Everything is fine. Suppose main memory is small. You cannot send 15 lakh lines of code at a time to main memory. So what I mean to say is, if at all possibility there, compilation, let me write now. If at all more memory there, more memory available, you can do total compilation at a time. Total compilation, 15 lakh lines of code will go to main memory at a time. From there, your program is compiling, right? Compilation. Let us assume that you have more memory. So total 15 lakh lines of code will go to main memory. From there, you can run at a time. This is called as single pass compiler. This is called single pass compiler. This is called single pass compiler. Suppose that, right? I done the compilation, right? More memory. Let us say less memory or less RAM, less memory, less main memory. Then total compilation cannot done at a time. So what will happen? First let us assume that 5 lakh lines of code will go to main memory. right? It will do 5 lakh lines of code, whatever can do, it will do with that output, next 5 lakh lines of code. With that output, next 5 lakh lines of code means total compilation in multiple rounds if you do. That is called as multi-pass compiler. That is called multi-pass compiler. Right? See this one. I want to compile a program. When you say compile a program, right? 15 lakh lines of code you have to run. Compiler is a software. 15 lakh lines of code you have to run. When you say run, this much code should go to main memory. Right? Means main memory can accommodate or not, I have to check. Suppose isn't that more main memory I have. Then 15 lakh lines of code will go to main memory at a time. Those 15 lakh lines of code is running. That is called single pass compiler. Suppose that less main memory I have. 15 lakh lines of code cannot go to the main memory. First it will go to first 5 lakh lines of code will go. It will run, right? On that output, next 5 lakh lines of code. On that output, next 5 lakh lines of code, right? Like that it will come. Total compilation if you do in multiple times, multi-pass compiler. Total compilation if you do at a time, single pass compiler. So please try to understand. Yeah, I think automatically changes will come. Now see this one. If you do total compilation, multiple passes, 5 lakh lines of code will go. Some work will be done. It will come back. Again, next 5 lakh lines of code will go. Some work will be done. Again, it will come back. Next 5. If you do total compilation in the multiple times, right? Compilation time is more. If you do total compilation at a time, one time going, one time coming, less time. So single pass compiler advantage is less time. Less time. This is the advantage. Drawback is more space. Drawback is more space. More space needed. Next one, multi-pass compiler. Multi-pass compiler. Advantage, less space. Please write properly. Drawback. Right? Advantage is going to be less space. Drawback is more time. So from this is the discussion, right? Please write properly. The discussion here is what is the meaning of compilation is going on. Remember, compiler is a software. Compilation is going on means 15 lakh lines of code is running. 15 lakh lines of code running means 15 lakh lines of code should be there in the main memory. But but main memory space may be less. If main memory space is less, so 15 lakh lines of code cannot run. So it should run in the multiple passes. So total compilation in the multiple passes, if you do multi-pass compiler. Suppose 15 lakh lines of code, right? Main memory can accommodate. At a time going, at a time compilation. So single pass compiler. If you do at a time, advantage is less time. If you do at a time, drawback is more space needed. If you do multiple times, right, advantage is with less space also you can manage. Drawback is more time. So please remember, in examination they may ask you, right, what is the advantage with the multi-pass compiler? What is the drawback with the single pass compiler? In the examination they will ask you. If you don't know the story, you may feel that complex story reddies are left out. You may say that complex story reddies are left out. Bacha things he explained, complex things he left out. If I don't say the story, you may feel that reddies are done. Bacha things, right? Papa things he left out. People will think multi-pass compiler. Some people will get a heart attack. As soon as they will listen the multi-pass compiler first time, they will die. Oh, multi-pass compiler. Reddy sir said that very simple compilation. Multi-pass compiler means so maybe many steps are there. So please try to understand. If you do total compilation in multiple passes, multi-pass compiler. First of all, why are you doing in multiple passes? Main memory is less. It cannot accommodate total code. So I am doing 5 lakh lines first. Next 5 lakh, and so on. So in the first 5 lakh, listen, in the first 5 lakh, maybe lexical syntax. In the next 5 lakhs, maybe semantic and intermediate code. In the next 5 lakhs, maybe code optimization and target code. Some people are saying, sir, 5 lakh lines of code also, it cannot accommodate. Maybe, right? Maybe I think 5 passes. Maybe 4 passes. Passes will increase. Suppose it can accommodate 8 lakh lines of code. 8 lakh, maybe 2 passes. It depending upon how much memory you have. If you have very less memory, still I can run. The only thing is more passes. So more time. Is it perfect? Is it perfect? Let me know if anyone having any doubt. Remember, compilation is going on means 15 lakh lines of code is running. Compilation is a compiler, is a software. Compilation going on. 15 lakh lines of code is running. Running means that code should be there in the main memory. Now, can anyone help you now? How many people will give? Listen, how many people will give? Your system, sees one, your computer on. What is the meaning? As soon as your computer is on, one person will be there in the main memory. Who is he? As soon as your computer is on, one person will be there in the main memory. Who is there? Your computer on means one person will be there in the main memory. Who is that? Operating system. Operating system is the one who will run always. Operating system is a one program. Whenever your system on, operating system is running. Oh, your computer is running means operating system. Your computer is on means operating system is running. Operating system running means it is a software. It should be there in the main memory. OS is, when you on the system, automatically OS will go inside main memory. It can run from the hard disk also, but it will, at the time your system become very slow. At that time your system becomes very slow. The program which will always run, as soon as you on system, immediately one program will go to main memory. That program will always run until your system will off. That is operating system. Right? In the similar way, when you compile a program, when you compile any program, oh, you are compiling. Compiler itself is a one software. That software should go to inside the main memory. So this is the story. Total compilation at a time, single pass compiler. Total compilation multiple time, multi-pass compiler. First of all, why are you going to multi-pass compiler? I have less memory. Total compilation I cannot do at a time. So multiple passes I will do. What is the advantage you will get? Less space also I can manage. What is the drawback? More time. Single pass compiler advantage, one time going, one time coming. So less time, but more space required. So please remember, so this is not that much important, but if I don't say, somewhere you will see multi-pass compiler, single pass compiler, you will die like anything. Right? Reddy sir, multi-pass compiler means compiler. Reddy sir said compiler. Multi-pass means, oh, many things left out. So be careful. Yeah, perfect. I think everything we done. Introduction to compiler, everything we done. Introduction to compiler, everything we done. Now write down. Write down everyone. First chapter. So introduction is over. Now see the first chapter. Write down lexical analyzer. This is the first chapter. Lexical analyzer. It depending upon how much memory you have. If at all time is more important, go for a single pass. Space is more important, then go to multi-pass. It depending upon. Right? If you have more memory, then go to single pass. According to your requirement. Now write down first chapter, lexical analyzer. Lexical analyzer. Can we start? First chapter, lexical analyzer. Can you say what is the purpose of lexical analyzer? What is the purpose of lexical analyzer? Everyone, whoever watching, can you say one time good evening? Whoever watching, can you say one time good evening? Say one time good evening. Everyone, say one time good evening. Yeah, fine. So first topic is the lexical analyzer, right? Everyone try to understand what is lexical analyzer, what exactly it will do. What is the lexical analyzer, what exactly it will do. So I will explain now. Everyone careful. So in my opinion, today's class is just started now. In my opinion, today's class is just started now. Observe properly. In my opinion, today's class is just started now. Just started. So try to get everyone lexical analyzer. So purpose of lexical analyzer, everyone know. Purpose of lexical analyzer, everyone know. Getting tokens, right? Dividing the given program into tokens, everyone know. That is the purpose of lexical analyzer. So I'm going to write one diagram now. See one time. Lexical analyzer. Careful everyone. Lexical analyzer. So this person is parser, which is also called syntax analyzer. Parser means syntax analyzer. Lexical analyzer, it is a syntax analyzer. Parser means syntax analyzer. It is a symbol table. Careful everyone, it is a symbol table. Request token. What is the meaning? I will explain. What is the meaning? I will explain. Take this diagram. Lexical analyzer, take this diagram. Upper one is request token. Niche one is send token. Upper one is request token. Below one is send token. A receive token, something like that. Request, receive. Request and receive. What exact meaning? I'm going to explain. Lexical analyzer. I'm going to explain. Just take this diagram. Yeah, fine. Now, after taking this diagram, can you see one more? First, listen, right? The thing which I'm going to do now, right? That one also, first listen, afterwards you can take. It is a program. Line number 1 in the program, row number 1, row number 2, row number 3, row number 4, 5, 6, and so on. Row number 20, row number 50, row number 75, row number 100. Assume this is the program. It is one of the program, user program. This user program contains 100 rows. Next one, column number 1, column number 2, column number 3, and so on. Column number 15, column number 8, right? 19, column number 20. Isn't the 20 columns? My program contains, right, 20 rows and 100 rows. I'm repeating once again. My program contains 100 rows, 20 columns. So this is the program. Roughly, this is the program. User program, remember. Within few minutes, you will get everything. It is a new chapter. Everything you will get within few minutes. Concentrate properly. This is the user program. Yeah, fine. Initially, right? Initially, cursor is here. Program at first character. See this one. Initially, I am there. Row number 1, column number 1. Initially, right? At this program, I am at first place. Row number 1, column number 1. It is a current status. I am not done anything until now. I didn't explain anything. One diagram I written. One program also. Roughly one program I written. Please listen from now onwards, everyone. Everyone listen. If anyone says, sir, I didn't get lexical analyzer, just I started. I written one diagram and one program also roughly. Whatever needed, that program I written. Now understand what I am going to do. Right? Initially, in the program, I am at the row number 1, column number 1. Now, one small question. Everyone, whoever watching, for all of them, one small question I want to ask you. For all of them, just I want to ask one small question. Lexical analyzer and parser, who will give tokens? Give answer. Lexical analyzer and parser, who will give tokens? Make it fast. Lexical analyzer and parser, who will give tokens? Who will create parse tree? Who will give tokens? Who will create parse tree? Lexical analyzer and parser, who will give tokens? Who will create parse tree? Out of these two people, who will give tokens? Who will create parse tree? Respond. Lexical analyzer and parser, who will give token? Who will create parse tree? Yeah, parser will create parse tree. Lexical analyzer. Parser means syntax analyzer. Parser will create parse tree, which is also called syntax analyzer. Lexical analyzer will divide the given program into tokens. Everyone know. But remember, everyone, right? Remember, this point many people don't know. Careful. This point many people don't know. People are thinking that lexical analyzer will divide the given program into tokens. Everyone saying that lexical analyzer will divide the given program into token. That is true. But you don't divide token whenever you want. Whenever parser want to token, then only you will create token. See this one. Right? See this one. Parser is requesting lexical analyzer. Hello, lexical analyzer, I got to know that you will make the tokens. Hello, lexical analyzer, I got to know that you can make the tokens. I need token. Please give token to me. Parser will ask the lexical analyzer, please give token. Because I want to create the tree, please give token. Whenever parser will ask lexical analyzer, please give token, then he will start. Then lexical analyzer then will start doing tokens. You don't do tokens by his own. Whenever parser request, then only lexical analyzer will create tokens. You may say that, sir, why parser is asking tokens? Without seeing token, how he create the parse tree? Without seeing the token, how parser can create a parse tree? You don't know. Parser want to create a parse tree, he need tokens. See, doctor want to do surgery, he need the scanning report. By seeing the scanning report only, doctor can do surgery. In the similar way, parser also, by seeing tokens only, he can create the parse tree. There is a doctor, he want to do surgery without the scanning report. How he can do surgery? Similar way, parser is saying that I will create a parse tree, but I need token. Accordingly, I can create the tree and all. Now, I think today morning also, listen, today morning I send the 2 links. Please, everyone, I think lecture number 16 in the TOC, lecture number 17, please can you complete these 2? Lecture number 16, lecture number 17, please can you complete in TOC? I'm requesting everyone. Lecture number 16, lecture number 17 in TOC, please complete. Now I will say one interesting story. Listen. Now I will say one interesting story. Everyone listen. If you observe clearly, listen. If you observe clearly, careful. If you observe clearly, see everyone. If you observe clearly, for identifiers, there is a one grammar. I goes to identifier, I goes to some story there. For every story, listen, identifier purpose in compiler, one grammar. Compiler means grammar. Compiler means rules. Compiler means conditions. Every condition you can write in the form of a grammar. So these are the grammar. See, this is the grammar. Identifier I goes to, some productions are there. These are called productions. Identifier I goes to, some productions are there. In the similar way, everyone listen. Boolean operator, Boolean expression BE goes to, some productions are there. Boolean expression, you know Boolean expression, what is the answer? True or false and not true, something like that. The Boolean expression goes to. So what I mean to say is, in the C language, for every person some rules are there. Grammar is set of rules. Compiler is set of rules. Remember this. Next one. In the similar way, arithmetic operators, arithmetic expression, it is also having some grammar. Something. I am not writing roughly, right? Just I am giving idea. I am just giving some idea. Identifier purpose, one grammar. Boolean expression purpose, one grammar. Arithmetic expression purpose, one grammar. Everything having grammar. Next one. If at all any keyword is there, keyword purpose also one grammar. Keywords. Everything, some rules are there. Something, right? Maybe I think here 3 rules. Identifier having 3 rules. Roughly I am writing. Boolean expression having 3 rules. Arithmetic expression having 3 rules. So if anyone want to get clarity, can you please do 16, 17? Because anyhow you have to study TOC. 16, 17 you study. No relation at all. 15th lecture, 16th one, no relation. Completely free. Happily you can study. I can teach again, but unnecessary. It is wasting your time also, my time also. Those people who are not done TOC. If you are not done TOC, please can you study 16, 17? Now study 16, 17. Total lectures you can study. After completion of the whatever subjects going on. Right? Remember everyone. Everything in the C programming, identifier purpose, one grammar there. Boolean expression purpose, one grammar there. Arithmetic expression purpose, one grammar there. Keywords purpose, one grammar there. And one more thing, right? So constant purpose, one grammar there. Everything having some rules. Within few minutes, everything okay. Don't confuse a little bit also. Within few minutes, everything okay. Now, last time. Sir, you do dinner after class or before class? So see, seriously, one class is going on. Are Ketan, seriously, one class is going on. You can play jokes afterwards. You can play jokes afterwards. Sir, can I study algorithm from your recorded? Yeah, do whatever you want. Do whatever you want. Yeah. So everyone see one time. Everyone see one time. Everyone see one time. Please observe properly. Parser saying that please give token. Parser is saying to lexical analyzer, I don't know how to create the parse tree. If I want to create the parse tree, tokens are required. Hello, lexical analyzer, please can you give token? Hello, lexical analyzer, please give next token. So lexical analyzer knows how to create token. So he will do his work. He will give token. Let's see what is happening. Now everyone listen. Now everyone listen this. Everyone listen. Initially, some people are asking, sir, initially, where is the parser, sir? Initially, where is the parser? You know very well, right? It will start from start symbol. It's almost like main. It's almost like main goes to. Yes means start symbol, main goes to some productions are there. Main goes to some productions are there. Now see what happened. Observe properly. So main goes to. So parser is at here. Start symbol. In the grammar start symbol, this may be yes. Normally we will say yes here. Normally we will say yes here. Let us assume that grammar is right. Parser is there initially. Start symbol, which is main. Assume that. Now see the answer. Now see the answer. So at this place. In the program, right? Can you see in the program who will present? In the program who will present? Parser will present or lexical analyzer will present? In the program who will present? In the program who will present? Parser is there in the tree. Parser is creating a tree. Parser nothing to do with the program. Parser nothing to do with the program. Parser is there in the tree. Parser is there in the tree. Parser is there here. Parser there at the start symbol. Parser there at the start symbol. Can you help me know who is there in the program? Yeah, Roshan, I will say afterwards. Roshan, I will say afterwards, man. In the middle, how can you ask? In the middle, how can you ask? Some serious story going on. Can you listen? In the program, who is available? In the program, lexical analyzer there. In the program, lexical analyzer there because we want to do tokens. Lexical analyzer is ready to do tokens. So lexical analyzer is there inside the program. You want to say that I am ready for tokens. I am there first place. I am there first place. Lexical analyzer is saying that I am there first row, first column. I am ready to do tokens. I don't do tokens directly. If parser will ask, I will do tokens. Now parser is there in the start symbol. Parser is there in the parse tree. At the start symbol is. At the start symbol is main. If you want, you can write yes also. This is main or yes, whatever you can call it as. No problem. Now see what happened. Now parser is saying that I want to create the tree. Hello, lexical analyzer, please give token. Please give token. Now observe everyone. Now observe everyone. What the lexical analyzer will do is, it will do some work. Because you know tokens, you know very well how to create token. What the lexical analyzer will do is, see this one. He will read one by one character. Lexical analyzer will read one by one character. Lexical analyzer will read one by one character. After reading one by one character, lexical analyzer, after reading one character, he got to know, because he knows very well about the rules and regulations. After completion of 3 characters, after completion of almost 3 characters, see this one, column number 1, column number 2, column number 3. After completion of 3 character, so he went to the 4th also, but the 4th one is not required. He got to know that this itself is a token. This itself is a token. This itself is a token. Now let us assume that Let us assume that this is int. This is int. Let us assume that it is a int. I think data type. We assume that it is a int. So it is a data type. Remember, data type purpose also. Data type purpose also. One grammar is there. Everything one grammar there. Everything one grammar there. Please be careful. So S goes to main goes to if at all data type, right? If at all data type, so there is a data type. If at all S goes to identifier, there is a I. If at all Boolean expression, there is a BE. If at all arithmetic expression, there is a AE. If at all keywords, there is a keywords. If at all constant, there is a constant. Now observe, everything ready. Now observe. Parser is asking, hello lexical analyzer, can you give next token? Can you give token? Lexical analyzer done some work. Lexical analyzer done some work, and he's saying that token is int, which is a data type. Token is int, which is a data type. Whenever he will say token is a int, which is a data type, immediately see the parser what it will do. So it will go from S to data type. He will go S2 data type. He will go S2 data type. He will take this production. S2 data type. He will take this production. Data type means one variable. Data type. He will take this production. Whatever he will say data, right? Data type means he will go S goes to data type. He will goes to data type here. Here again he have some doubt. Which one he have to take? There are many things are there. Which one he have to take? Which one he have to take? So integer you have to take. So int. So data goes to int. Accordingly, you will take. So parser will ask lexical analyzer, please give token. Please give token. Accordingly, I will decide. So he is given the token into, which is a data type. Into, which is a data type. He will say integer type token. Integer, which is a data type. Then immediately will go S2 data type. Data type goes to into, like that. Like that he will go into. Right? Like that he will go into. Into followed by if anything is there. Suppose assume that. Here suppose assume that. Into followed by. Everyone listen. Into followed by ID, some identifier. Then immediately data type goes to int followed by some identifier. So first token already int came. So right, parser asked the first token. He done some work. He is given the int. But according to grammar, data type goes to int comma ID. So parser is expecting next token should be ID. Because whenever he asked the first token, it is given into. But according to the grammar, data type goes to int comma ID. So next token is expecting ID. Then what the parser will do is, parser will ask, can you give please next token also? When you do next token, he will do some work. He said that next token is ID. Right? He will read a few more characters. Let us assume that 5, 6, 7. Guarantee everyone will get. Listen few minutes. Everyone will get. Until 15 is over. He got to know next token is ID. So according to the rules, means according to the grammar, after into ID should come. Next one ID should come. Okay, K. In the similar way, he will ask next token. Like that, every time listen. Every time parser will ask next token. Lexical analyzer will give next token. So accordingly, he will see the grammar production. Whichever matching he will go. You don't go blindly. He will always ask in the program who is the next person. Parser will ask. Lexical analyzer will give. Based on that particular one, he will ask all the grammar. In the grammar, everyone he will ask who is suitable to me, because in the program next person is this person who is suitable to me. Like that, he keep on asking. Listen, he keep on asking like that. One more. Right? This is for first line. Maybe second line. Maybe second line, some other story. Let us assume that maybe, right, second one, everyone listen, second one, right, he's asking second one, what is the next token? Everyone observe. What is the next token? He done some work. Listen, he done some work. So he said that next token, again ID. Next token is again ID, he said. ID, identifier. So S goes to identifier, ID. So he will go ID story. ID, next token is identifier. He will goes to S goes to ID identifier. Identifier internally contains some production. Right, you have a doubt which one you have to take. Identifier, one of the identifier he will take. So like that, whatever he will say, one of the grammar production is matching, is keep on going like that. Let us assume that one of the identifier, assume that one of the identifier, let us assume that ID, okay, fine, that's okay. Next, let us assume that he asked ID, so I given, everything is fine. He will ask next token. Can you say in the lexical analyzer, right, in the parser is at which place? I think almost like 18. Parser is there at 18. Let's check. If anyone having small doubt also, wait a few more minutes, you will get the clarity. 18. Next one. He will ask next token. Let him that ID over. He will ask next token. Next token is, let us assume that he said that arithmetic expression. He said next token, some arithmetic expression. He will say next token, some arithmetic expression. So some arithmetic expression kind of stuff. So after doing little bit of work, 19 and 20. After doing 19 and 20, he got to know some other story. Maybe let us assume comma. What is there in that? Comma, whatever possible. So he said comma purpose, some other thing is there, right? Let us assume that S goes to comma. So he may take this. So always remember, whatever he will give token, accordingly he will ask the grammar. In the grammar, one of the person will match. So like that is keep on proceeding. Let us assume that one more incident. Observe everyone. One more incident. Let us assume that one more incident. Please listen everyone. Everyone have to listen. Yeah. Something like arithmetic expression. Go to arithmetic expression. Arithmetic expression normally contain, I think, some arithmetic expression. Let us assume that ID, everyone listen, some arithmetic expression which contain ID star ID, some identifier multiplication. So whenever he say what is the next token, whenever he will ask next token, see this one, I think this line is completed. 20 also completed means it will become 21, but 21 column is not there. So that is the reason he will change the row number 2. Now column number again starting from 1. So again he will start. Let us assume that it is given arithmetic expression. So I taken, right, parser is taken. S goes to, right, main goes to arithmetic expression. Arithmetic expression contain many people. You have again doubt. In the arithmetic expression, what you have to take? Let us assume that in the arithmetic expression, if you observe, right, assume that here ID came. ID. So he will ask which ID I have to take. So approximately, see this one, approximately ID. Yeah, ID. He is given the token as ID. So I taken this particular production. ID star ID. If anyone is having small doubt, please have patience a few more minutes. He asked the next token, arithmetic expression. In that first token is ID. So he asked which one will give ID is taken. That's okay. But as per the rule, after this ID, star required. So right, parser is thinking that next token which is going to come is star operator. Next token which is going to come is star operator. As usual, he will ask, please say what is the next token. In the next token, instead of star, he said again ID. But parser is expecting, as per the rule, parser is expecting next token is star operator. But right, but a lexical analyzer is saying next token is ID. Parser is rules are saying that star should come next to. Lexical analyzer saying that next token is ID. He is expecting star, but he is giving the ID. They both are mismatching. So this is called syntax error. According to the grammar rule, next one should be star operator. But lexical analyzer is saying that next token is ID. Lexical analyzer is saying that next token is ID. As per the rules, next token is ID, star required. So parser is expecting star, lexical analyzer is giving ID. There is a mismatch is going on. It will give error message, syntax error. Now listen. If anyone having small doubt, you no need to confuse. Just say only one thing. Who is making tokens? Confirm. Those people who confused, please give answer. Who is making tokens? Everyone respond. No need to confuse also. Yeah, if anyone having doubt, I will clarify. Please give my answer first. Who is making tokens? Who is creating parse tree? Who is making tokens? Who is creating parse tree? Please give answer. Everything will be okay. Nothing. No need to bother that much. Who is making tokens? Lexical analyzer. Who is creating parse tree? Parser. And one more. Whenever parser is creating parse tree, so many productions are there. Which production I have to take? How I know? Whenever parser want to create a parse tree, so many grammars are there. See, very big grammar. Approximately, see this one. This everyone is a one production. Production number 1, production number 2, production number 3, production number 4, production number 5, production number 6, production number 7, production number 8. Like that, there are 10 crore productions are there. Parser having 10 crore production. Parser having doubt. Which production you have to take? Parser having doubt. Which production you have to take? You have serious doubt. So that is the reason you don't go grammar directly. You will ask the lexical analyzer, hello lexical analyzer, please say next token. According to your token, I will select the production. If I want to take the production out of 10 crore, I don't know which one I have to take. So parser will request the lexical analyzer, hello lexical analyzer, please give token. So that out of 10 crore production, I will decide which one I have to take. Because out of those 10 crore, I can take anyone. Out of those 10 crore, I can take anyone. But I have doubt. Because to this program, which is suitable, I don't know. Please give token. Then what he will do is, lexical analyzer will read the program and he will say who is the next token. If the next token is keyword, he will take S goes to keyword. He will go to 5th production. If the next token is a constant, he will go to S goes to constant. 6th production he will take. Suppose S goes to comma, he will take 7th production. Based on the token, he will take the production. Based on the token, he will take the production. Suppose assume. Based on the token, everyone observe. Based on the token, he taken this production. Let us assume some incident. One of the incident I am talking. Lexical analyzer is given one token. According to that token, parser is taken this production. Let me say production number 55, some number. Parser is asked the lexical analyzer, please give next token. He given next token. According to that one, right? This parser taken 55th production. In the 55th production, right? So because the parser said, listen, lexical analyzer said that first token is ID. According to that rule, is taken this production. It is the 54 also there. Because of lexical analyzer said that first token is ID. So in all of them, first token ID is this person. So parser is taken this production. But this production given not only ID, some extra also there. Now, so as per this rule, because of this one, parser taken this total production. But as per this rule, next one should be star operator. Then he asked right? Then parser asked the lexical analyzer, please can you give next token? He is given next token, again ID. But as per the rule, star operator should come. See here. As per the rule, whatever is taken, star operator should come. If anyone is confused, nothing. Try to get ID. Right? Yeah, because of this token, parser is taken, this production number 55 taken. But according to 55, next to two people should be star and ID. Then he asked the lexical analyzer in the program, who is the next person? In the program, who is the next person? Next person instead of star operator, again ID, but he is expecting star operator. This is called syntax error. Rule is saying that after ID, star ID should come as per the rule. But in the program after ID, one more ID came. In the program after ID, one more ID came. But as per the rule, after ID, star should come. This is the place error. This is the syntax error. So one thing understand. Parser having 10 crore production. He is having doubt which production he have to take. So he will ask lexical analyzer, please give token. According to token, I will match the required one. Out of those 10 crore, whom I have to take? You give token, accordingly I will go. Suppose isn't that he given some token, right? According to that token, matching number is a 55. So 55 production I am taken. Token is ID. For that ID, matching production is 55. I taken. But according to 55, further story is star ID. So parser expecting star ID, right? Parser asked the lexical analyzer, can you give next token also? In the next token, instead of star, there is a ID. So parser got to know there is a syntax error. Programmer written something wrong. So remember everyone, lexical will give tokens. Parser will create parse tree. But creating parse tree means you have to take productions one by one. See, this is one production. This is one production. You have to take one by one production. You don't know which production you have to take. According to program, you have to take tokens. So lexical is giving token. According to token, you will take production. So every production is nothing but a rule. So according to this rule, next one should be star ID, but is giving ID. Program saying next token is ID. Rule is saying next token star. There is a mismatch. So this is called syntax error. And one more thing. Listen, one more thing. Right. Right, fine. So can you help me one small line? Can you help me one small line? Everyone listen. Can you help me one small line? Just I want to ask everyone one thing. What is the error message came? Observe everyone. What is the error message came? Who identified error? Everyone give answer. Who identified error? Parser asked the lexical analyzer, please give next token. So in the program he read, let us enter which place is this one. Whenever this token came, is there column number 14. Everyone observe. Whenever this token came, is there column number 14, row number 2. Row number 2, column number 14. Everyone listen. Row number 2, column number 14. Whenever he got the token second ID, token second ID, at that time parser expecting star. Lexical analyzer is given ID, both are not matching. There is a error. Can you help me now? Who identified this error? Parser. So what the parser will do is, he will go to error handler, he will inform. Parser will goes to error handler. Hello, error handler, as per the rules, I am expecting star operator. But lexical analyzer is giving token ID because programmer written ID. As per the rule, as per the previous, listen, because of previous token, I taken the 55th production. Lexical analyzer is given the previous token. Because of previous production, I taken the 55th production. 55th production I taken because of previous token. As per the 55, next token should be star. I asked the lexical analyzer, instead of giving star, he is given ID. I asked lexical analyzer, why are you giving ID? Programmer written ID. What can I do? Whatever programmer written, I give him. But rule is saying that star operator, programmer written ID, so they both are mismatching. Oh, programmer not followed the rules. So lexical syntax analyzer will go to the error handler. Hello, error handler, my name is parser. Hello, error handler, my name is parser. Means you have to write in the error message, after compilation is over, in the errors you have to write, there is a parsing error or syntax error, because I am the person, my name is parser, syntax analyzer. So whenever syntax analyzer informed to right error controller, hello error controller, my name is a syntax analyzer, I find out some fault. So lexical, right, syntax error handler will note down syntax error. Syntax error. What is the syntax error? Star expected, but ID came. So he will note down syntax error. Star expected, but unfortunately ID came. And one more beauty. See the one more beauty. Whenever that error came, everyone observe. Whenever that error came, lexical analyzer is there in the 14th column, second row. Lexical analyzer that time there in the second row, 14th column. Now see what the error message. Everyone observe. This is the error message. What they will write. See the error message. See the error message, everyone. After compilation, you will see on the screen. See this one. Row number 2, column number 14. Row number 2, column number 14. Syntax error. Syntax error. Star expected, but ID came. This kind of error message he will give. I hope now everyone got. The problem what the parser is facing is 10 crore production, which production I will take? 10 crore production, which production I will take? Parser having serious problem. To solve that problem, he will ask lexical analyzer. Hello, lexical analyzer, you can read the program. Please read program. Please say what is the next token. Whenever he will give next token, out of this 10 crore production, which is the matching one, that production he will take. But whenever you say production, it is a set of rules. So based on the first person, see, previous token is ID. Based on this person, I taken the 55th production. But 55th production saying further should be star ID. But in the program next token is right ID. But here star. So there is a error. Now my first question to everyone: who given row number, column number? My first question to everyone: who given row number, column number? My first question to everyone: who is given row number, column number? Everyone please respond. Lexical analyzer, because he is the one who is reading the program. Lexical analyzer is scanning the program. He knows where is he. He knows where is he in the program, at which place he is given the token, he knows. Lexical analyzer will give row number, column number. And one more, who will inform to error handler? Syntax analyzer is informing. So syntax error. Syntax analyzer informing to error handler, hello error handler, I am a syntax analyzer. So I got one error. I am expecting star, but a token coming is ID. As per the rules, star should come because I taken the 55th rule. In the 55th rule, after ID, star should come afterwards ID. But unfortunately, star not coming. Next token is ID. Lexical saying next token ID. But rule saying that star. So I think there is a mismatch. Programmer written wrong. Programmer written wrong. So note down syntax error. Star expected, but ID came. Immediately error handler will ask the lexical analyzer. Hello, lexical analyzer, I got to know error message. Please let me know at which place you read the token. Because you are the one who is scanning the program. Please let me know at which row, which column you are. He will say row number 2, column number 14, right? I give in the previous token. So please note down. Immediately syntax analyzer will say, I am expecting star as per the rule, but unfortunately ID came. So syntax error, star expected, but ID came, row number 2, column number 14. Whenever it see new line character, whenever it will see new line character in the program, new line character. So you will go to next line. Automatically you will go to next line. Someone is saying how to identify which row and which column. Give error message, right? So this is the case. See, at that time lexical analyzer, see, for every character reading, right, column number will increment by 1. See, right, first character, second character, third character. So column number is keep on increasing. Whenever, right, one of the character is null character, new line character, sorry, /n. Whenever new line character, you will automatically shift to, right, again column 1, row number 2. Like that, it will change. Whenever new line character, you will increment, right? So column becomes 1, row becomes the next one. Like that, it will keep on changing. Every character reading, C will increment. Whenever next character is a new line character, C will become 1, R will goes to R plus 1. Like that, rows and columns are keep on updating. So it's very simple. See, it's a very simple. The purpose of this one, I want to inform to everyone. Lexical will give tokens. Lexical will give tokens. Parser will create parse tree. But remember, parser create parse tree. Whenever you say tree creating means tree contain productions only. Listen, tree contain productions only. Everything is production. See, this is one production. This is one production, right? So this is one production. This is one production. Whenever you say tree is nothing but productions only. So out of these many production, which production I have to take? So he will guide. Lexical analyzer will guide. First token is this one. Take the production number 3. Next token is that one. Take the production number 8. Right? So based on the token, he will decide which production. Based on the token, you will select the which production. But whenever you say production, see, there may be a chance that many people in the production. Some productions may be only one person there. Some productions may be only one there. Some productions may be more there. Some productions may be like this also. Some productions may be like this also. ID star, ID star, ID. It depending upon production. It depending upon production. Right? So according to the rule, see, because of this person, I may be taken this, right, this production number. But afterwards, something else expected. But the token may be something else. It may be something. Then there is a syntax error, something like that. Okay, fine. Now you can ask me doubts. Do you have any doubts? Do you have any doubts? Let me know. Someone is saying, for error message, row less than column, what is the relation? No relation, right? Why you keep unnecessarily? Row less than column what? When, see, if you go further, row number may be 50, column number may be 7. Row number may be 50, column number may be 7. There is a problem. When you proceed further, rows will be increased. Rows will be increased, right? One by one row I am going, one by one row I am going. Remember everyone, in the program, for every row, one tree will come. Yesterday's class, if you observe, x is equal to y plus z star 60, one tree came. For every, listen, for every line, one tree will come. For every line, see, for the first line, this tree will came. For the first line, this tree came. First line of the program, this tree came. Second line purpose, maybe this came. Third line purpose, maybe this came. So every row, one tree will come. All are connected by start symbol. All are connected by start symbol. Yesterday's class, if you remember, one line, one tree. So second line, one more tree. Third line, one more tree. Fourth line, one more tree. These all trees are connected to start symbol, which is the main. Fine. Fine. Is there anyone having doubt? Yesterday, listen, yesterday people are thinking that, listen, yesterday people are thinking that in the yesterday's class, people are thinking that lexical analyzer will give fully tokens. Some people are thinking yesterday, lexical analyzer will give all tokens at a time. Parser will create the parse tree at a time. No, bhaiya, all will synchronize each other. All will synchronize each other. In our class, this is one. In this class, how we all are synchronizing each other. In this class, how we are synchronizing each other. Sometimes I will stop. Sometimes you will stop. Sometimes I will ask. Sometimes you will listen. Sometimes you listen. Sometimes I will ask. So it is a nice story going on. Nice story. Whenever I am talking, you don't talk. Whenever you are talking, I don't talk. Some compromise is going on here. Same thing here. Same thing here. Lexical analyzer, parser, both are cooperating each other. Because of I know token, I cannot do 35 tokens at a time. There is no meaning. All tokens I will do, right? I will do at a time to parser. What it will do? So whenever parser will ask token, he will give. Whenever parser will ask token, he will give. They both are synchronizing like this. Based on the, listen, based on the next token, next production will be selected. Tree means productions. If you see the tree, everything is a production. See, this is one production. This is one production. Right? So this is one production. So everything is a production. Right? Which production I have to take? Based on the tokens, it will come. So if anyone having small doubt also, now only started compiler. You cannot get everything now. Just I am giving the connection, how they are connected. Listen, yesterday people are thinking that, lexical is over. Syntax will start. People are thinking like that. In the yesterday's class, people are thinking lexical will come first, syntax will come next. No, bhaiya. He will give tokens. He will create parse tree. They all will synchronize each other. Whenever syntax analyzer will say, I want to create tree, I have a problem, lexical analyzer, please give next token. Accordingly, and one more beauty, listen, one more beauty. Everyone listen, one more beauty. I am saying everyone have to listen this also. If you can listen this also, you will get the full clarity. If you can listen this also, you will get full clarity. Let us assume, is it ID? Listen everyone now, let us assume that it is ID. Remember, for every ID, for every identifier, token number given. Let us assume that its token number is ID, 1. Whenever it is a ID, there is a token number. Whenever it is a ID, there is a token number. There is a token number. He will go inside, listen, he will go inside the symbol table. Let us assume that it is a symbol table. Careful. Whenever it is a ID, compulsory, there is a token number. So ID 1 means it is there in the first row. Can you see this one? First row, ID is X. So let us assume, this type may be float. Assume. This type may be float. Assume that. So this type is float. But let us assume that in between there is a assignment operator. Just observe, just observe. In between some assignment operator, let us assume this side also ID there, this side also ID there. This is ID2, this is ID2. Let us assume that here also ID there. Here also ID there. Let us assume it is ID2. If I go to second row, Y, it is int. Observe properly. Whenever you say ID, every identifier having token number. Let us assume that this token number is ID2. If I go to second row, I got to know it is an integer. So integer equal to. Again it is ID. Every identifier having the token number. ID1, symbol table first row, float. Trying to store float in the integer. You are trying to store float in integer. ID2 is an integer. You are trying to store float inside integer. You will lose data. Am I right, Amma? I think type mismatch error. Trying to store float in integer. 4 bytes data you are storing in 2 bytes. You will lose data. So it is going to be error message. Now remember, whenever you are checking the types, type means semantic error. So semantic analyzer also will come at a time. Whenever identifier, immediately semantic analyzer will come. Whenever identifier, immediately see it is identifier. Semantic analyzer will come and will check what is the type. In the symbol table second row, there is a int there. Whenever identifier, immediately semantic analyzer will come. ID1 in the symbol table first row, float there. Oh, you are trying to store float in integer. So type mismatch. Bigger one you are trying to store in smaller one. You will lose data. Type mismatch error. Let us assume that whenever this story came, right? So lexical analyzer is there. Row number. Let us assume row number 85, column number 3. This incident happened. Assume. Then it will say because of semantic analyzer, semantic error. So I am writing here row number 85, column number 3. This story happened. Float you are trying to store in integer, which is going to be type mismatch story. Semantic error. Right? So that is right type problem. Type mismatch error. Whenever identifier will come, immediately semantic will come. Is it identifier? Yes. Immediately semantic will come and will see what is the token number. ID2, symbol table second row, integer. Whenever ID came, immediately semantic will come. So token number ID1 in the symbol table first row, float. So trying to store float in integer. Bigger one in the smaller one, you may lose the data. So error message. So which row? At that time, lexical analyzer, 85 row, column 3. So row number 85, column number 3, syntax error, type mismatch like that. So what I mean to say is lexical, syntax, semantic, all three will work at a time. Everyone will do their part. Lexical analyzer doing tokens, parser creating parse tree, semantic analyzer doing type checking, all three done at a time. Suppose assume that all are not doing at a time. Can anyone guess how many scans will happen? Suppose assume that all three people are not doing at a time. All are doing one after another. Can you say how many scans? All are doing one after another. How many scans? Lexical will do total program 1 scan, n time. Lexical analyzer will do total program 1 scan. Right? Next one. Lexical analyzer will do 1 scan. Next one. Parser to create parse tree, 1 more scan. Semantic analyzer to do type checking, 1 more scan. Totally 3 scans. If all will do individually, 3 scans. If all will do at a time, 1 scan. In 1 scan, all people are communicating. All people are collaborating each other. You only say, you and me, both are collaborating. That is the reason in one class only, both are going on. You are doing your work, I am doing my work. In one class only, all people are doing work. You are doing your work. Wherever doubt, you are asking. Whenever possibility there, I am explaining. So we all are communicating at a time. That's the reason. In one class only, everything happening. Some students in one class only, they are listening also. They are writing notes also. Some people in one class, they are listening only. They may write afterwards. So, right, that is the meaning of collaboration. We all are collaborated. So in one class, everything happening. So in one scan, end time all. You only say at a time, if you do, you can save the time. You can do one after another also. Lot of time will waste. Now it is the correct time to ask you. Lexical, syntax, semantic. Are they working one at a time or combinedly? Lexical, syntax, semantic. Are they working at a time or one after another? Lexical, syntax, semantic. Are they working at a time or one after another? Lexical, syntax, semantic. Are they working one at a time or one after another? All at a time. All at a time will work. Everyone will do their work. One person doing tokens, one person doing creating a tree, one person will do semantic checking, all the things. If they do combinedly, they can save a lot of time. So see, the purpose of this entire story to give that clarity. Nothing will come in the examination from this. For your convenience, yesterday I cannot say this story. Yesterday I said systematically one by one. Yesterday I explained systematically one by one. Lexical analogy will do what? Syntax will do what? Semantics will do what? I explained one after another. You may be thinking in your brain, same imagination will be there. You may be thinking like that, but I want to say that it is not like that. So you will start doing tokens. You will start creating parse tree, but parse tree means all these production. I don't know which production I have to take. I written some randomly. Don't think much. Some randomly I written. Out of these 10 crore production, which one I have to take? I have doubt. So see the program. See the program is lexical. Lexical will see, he will say next token is this one. According to this token, take this production. So my next token is this. So production number 7 you have to take. So parser will take 7. Again he will ask, hello lexical, can you give next token? Right? He will say next token is that. You have to take production number 10. He will take production number 10. Again he will say next token is this. Production number 50 you have to take. He will take production number 50. But according to production number 50, next token is a star. But lexical saying that next token is ID. Whatever he said I done till now, but according to whatever he said previously, I taken production number 55. In that production number 55, next token expected star, but lexical saying next token is ID. So both are not matching. Previous token whatever given, current next token whatever he is saying, some problem is coming. Because production number 55 saying whatever he is saying lie. Oh, programmer written something wrong. So he will say, right, whoever facing this problem, syntax will inform to error handler. Right, this place I faced this problem. Error handler, can you give error message? Syntax error. Then immediately we'll ask the right lexical analyzer at which row, which column you are facing this problem. This row, this column. So you will note down everything. After compilation is over, you will print all error messages. Whatever you note down, whoever inform. If semantic inform, you will say semantic error. If semantic inform, you will say semantic error. If syntax will inform, you will say syntax error. But every time you will ask the row number, column number. Row number, column number known by only lexical analyzer. Only lexical analyzer. Okay, whatever you got, it's okay. In my opinion, all people got clearly. If you don't get also, no problem. If you don't get also, no problem. No need to bother. No need to bother. Whatever you got, it's okay. Can you write a few points here? Can you write a few points here? First point. Write the first point. Lexical analyzer Write the points one by one. Almost you are okay. One or two doubts also there. These things will clarify. So sir, the token number is given only for the user defined thing, right? Token number. See, all are tokens only. Everything is token, but token number will be given only for identifier. Now let me say interesting answer. Everyone listen. Everyone listen. A is equal to, nice question. See the nice question. See this one. A is equal to B plus C. Everyone observe. Everyone observe this. A is equal to B plus C. A is a identifier type token, but it is identifier. Token number also given. A comma 1. Next one. Assignment operator. It is also token. B is a token identifier. Token number given because they stored in the symbol table. B2. Next one. Plus is a token, but because of it is already right. Compiler knows you don't give any token number. It is also token. Next one, C, identifier. It is a token identifier. You will give token number. So C comma ID comma 3. ID comma 1, ID comma 2, ID comma 3. Token numbers given only for identifiers, but every one is a token. These all are tokens. Nice question. Thank you so much for asking. Thank you so much for asking. Further, anyhow, you see that. Let me go further. Write down now. Lexical analyzer is first phase of the compiler. Right, everyone? Lexical analyzer is first phase of the compiler, which divides given program into tokens. Lexical analyzer is the first phase of the compiler, which divides given program into tokens. Because of that reason, lexical analyzer is also known as scanner. Because of that reason, lexical analyzer is also known as scanner. Lexical analyzer is the first phase of the compiler, which divides given program into tokens. Because of that reason, it divides the given program into tokens, means is clearly scanning everything. So that is the reason lexical analyzer is also known as scanner. Okay, that is fine. 2. Different types of tokens are. When you say token, which type of token? Different types of tokens are roughly identifier type token. No one will ask you for your convenience. Identifier type, keyword type. Next one, operator type. Inside operator, again some more divisions are there. Right? Maybe arithmetic operator, relational operator, Boolean operator. Simply say operator. Next one, constants, separators, or some special symbol. If you want, you can write special symbol. Remaining all, let us use that special symbol. Remaining all, maybe comma, maybe semicolon, maybe bracket. Special symbols. Within the brackets, I'm writing maybe comma, semicolon. Next one, maybe bracket. something like this, right? Keywords, sorry, operator, maybe plus, maybe star. No one will ask you. If at all they will ask, I will go a little deeper. If they are not asking, why should I go deeper? Plus, star, divide, minus, R operator, end operator, double end, and so on. Constant, maybe 60, maybe 70, 80.5, some numbers. Keywords, maybe if, return, some more like this. Identifier, maybe some name A, maybe B, maybe fun function, right? Some names, maybe variable where. Different types of tokens are identifier type token, keyword type token, operator type token, constants, special symbol. Lexical analyzer is the first phase of the compiler which divides the given program into tokens. Next one, types, different types of tokens are roughly I written. Yeah, only identifier will go inside symbol table. Only identifiers will go inside symbol table. So remember the above story, whatever I said. If I don't say above story, you feel that. If I don't say above story, you feel that lexical will come first. No, bhaiya. All three will work simultaneously. Always cooperation required. There is no strict rule. Prime Minister, Home Minister, who is great, they both should cooperate. If they don't cooperate, they will fight each other every day. Prime Minister, Home Minister, always, right? In my opinion, they always should be friends. For the Chief Minister, who is very close, that person will be selected as the Home Minister. Otherwise, they both will fight always. For the Prime Minister, who is very close, that person will be kept as a Home Minister. Otherwise, they both will fight. And one more, to the Prime Minister, whoever very close, those people will be selected as the ministers. Otherwise, they will fight always. They all should cooperate each other. If they don't cooperate each other, system cannot run. Are you getting? Whenever three people are working, they all should work together. They cannot work individually. If they work individually, problem will come. Lot of time will be wasted. Only lexical. Lexical said that I will do first. Other people I don't help. Then one scan. Semantic will said that I will do one scan. Like syntax will said that I will do one scan. Okay, do everyone one scan. Lot of time. Someone is saying Modi, Shah, Yogi. If I keep my leg inside your mouth, don't bite me. If I keep my leg inside your mouth, don't bite me. Are Vipul? If I keep my leg inside your mouth, don't bite me. Again and again, I'm requesting you. But if you keep your leg inside my mouth, definitely I will bite you. Definitely I will bite you. What is going on? What you are talking? Are Gutle? I'm talking seriously some story. You are saying Yogi, Modi, Shah, all are friends. What exactly said? They both are friends. Very serious story going on. You are playing jokes. Right, I think you people got to know. See, some people, see, that is the reason everywhere patience is required. Are you getting or not? Everywhere patience is required. Do you believe or not? Do you believe or not? Everywhere patience is required. See, whenever the story going on, see, some people dropped. Whenever this story going on, some people dropped. Are bhaiya, the purpose of this one, I want to say, they all are cooperating each other. Nothing will come in the exam. Nothing will come in the exam. Just I want to say how they will synchronize. Everyone doing their work. See, when class going on, I am writing on my board. You are writing on your notes. When our class is going on, I am writing on my board. You are writing on your notes. I am talking, you are typing. Some jokers came in between, they are playing jokes. Right? Everyone doing their work. So similarly here, lexical doing, token, syntax doing, right? Parse tree creation, semantic doing, semantic checking, everyone doing their work, but yet a time. Otherwise, many scans will come. Unnecessarily time waste. Similarly, when our class going on, everyone done. See, I am writing. Sometimes I am scolding. Sometimes I am blocking. I blocked one or two people also. Right? I blocked one or two people also. I am writing, right? I am talking, right? Sometimes I am scolding. Sometimes I am blocking, right? Because someone is asking, I am hungry. I am hungry. I have to take dinner. What should I do? Someone is saying that I am hungry. I want to take dinner. So I blocked him saying that go and take dinner. Right? I don't want to waste the time and all. I simply said indirectly, go and take, right? Don't block me. Someone is saying, seriously, class going on. One person came, said that I am hungry, I want to eat. Then I said, go and eat. Give dinner, sir. Okay, eat. Neha, eat this. Neha, eat this. Cake. Eat this. Neha, please eat. Eat this mouse also. So tasty, sir. Just shut up. Neha, just shut up. Right? See, that is the reason people used to say, that is the reason people used to say you should have patience. See, one story going on. I want to convey to all of them. They all are synchronizing. One person cannot do directly. Everyone, that all three people are synchronizing. They are doing like this. Okay, fine. These are the main points. Whatever you got from that only these conclusions. So lexical analyzer divide the program into tokens. That is the reason it is known as scanner. Different types of tokens are I written. Next one. Everyone listen. Very interesting question. Listen. Very interesting question. In the program, comments for user purpose or compiler purpose or processor purpose. In the program, comments are for the purpose of whom? In program, comments written for the purpose of whom? User, compiler, or processor? User, compiler, or processor? User purpose only. That is the reason whenever compilation is going on, whenever you see comment line, you will eliminate it. Because right, compilation purpose is converting high level to low level. What is the requirement of converting the comments? So right, one more purpose of the right lexical analyzer is tokens is one purpose. One more purpose is going to be it will eliminate comment line. It will lexical analyzer eliminate comment line, means it don't count. Lexical analyzer will remove comment lines, means it don't count as a right token. That means in the tokens you don't count. Lexical analyzer will remove comment lines. Next one. Lexical analyzer will remove white space characters also. Lexical analyzer will remove white space characters also. Lexical analyzer will remove white space characters also. Some people are asking, sir, what is the white space character? Can you see everyone? I want answer from you. How many tokens here? I am expecting answer from everyone. How many tokens here? I am expecting answer here. How many tokens? Int a semicolon. int a semicolon. How many tokens? Int a semicolon. How many tokens? Chaman is saying that good evening, sir. Good evening, Chaman. Good evening. Good evening, Chaman. Good evening. So how many tokens? 3. See this one? It is one token. It is one token. It is one token. See, this white space, it don't count. This is called white space. White space means blank. White space means blank. Let me write now. White space contain. White space contain. So I'm writing here blank. New line. New line character. Blank and new line. Lexical analyzer will remove white space character. Means it don't count as a token. It don't count as a token. Please be careful. That's the 4th line. 5th line. Lexical analyzer will help. Lexical analyzer will help in giving error messages. In giving error messages by providing row number, column number. Whenever error happened, he will provide the row number, column number. It's a very, very important task. If row number, column number not there, right, user don't know where is the error. Suppose assume that after compilation is over, you got 5 errors. You don't know row number, column number. Where you fix it? How to fix it is a serious issue. So this is the one of the greatest functionality of lexical analyzer. Lexical analyzer will help in giving error messages by providing row number, column number. This is the very, very important functionality. He is the only one who knows. He is the only one who knows row number, column number, because no one will touch the program other than lexical analyzer. Lexical analyzer is the only one who knows whenever this error came, at which row is there, at which column is there. Lexical analyzer will help in giving error messages by providing row number, column number. If you don't provide row number, column number, serious issue. Suppose my program contains 10 lakh lines of code. I done the compilation. I got 500 errors. Row number, column number not there. Where I will check? Program contains 10 lakh lines of code. Where I will check? So definitely it will waste lot of time. So lexical analyzer is doing the great help by providing row number, column number whenever error came. So these are the 5 functionality. Anyone having any doubt, let me know. Anyone having any doubt, let me know. Anyone. If 5th functionality not there, no one will become developer. If the lexical analyzer don't provide row number, column number, lexical analyzer don't provide row number, column number, trust me, no one will become a developer. Because unfortunately, error will come. You don't know where to check. Unfortunately, error will come. You don't know where to check. Someone is saying, who replace macros? Arey, Vipul, one time if I beat you, your hand will go. Can you help me know? Macros will be replaced by preprocessor or not? Macros will be replaced by preprocessor or not? Before compiler, there is a preprocessor. Preprocessor will replace all shortcuts by actual. He is not part of compiler. He is a before compiler. He is a before compiler. So if you want, you can write that also. If you want, you can write that also. Note. Thank you so much, Vipul, for asking. Note. Macros. Macros means hash defined like that. These are macros. by preprocessor. Macros will be replaced by macros will be replaced by actual by preprocessors. Replaced by actuals by preprocessor. Remember this. I think people going to block very soon. I think people time is very close. By seeing all the chat, I can say, by seeing all this chat, I can say his lifetime is very close. He will be blocked soon. He will be blocked soon. Macros will be replaced by actuals by preprocessor. Yeah, can we stop? Now, can anyone help? Comments are, listen, comments are shortcuts for user convenience. Comments are shortcuts for user purpose. Comments are shortcuts for user purpose. So preprocessor will not come. Preprocessor only for macros. Preprocessor for macros. Right? Comment lines will be done by compiler. Compiler got to know this is for user convenience. He will skip it. You don't count. You don't count. Can you help now? Can you help now? Comment lines will be there in parser. Comment lines will be there in the parse tree. Comment lines will be present in the parse tree or not? Comment lines will present in the parse tree or not? Bhaiya, no. Because lexical analyzer never give token, which is the comment. Lexical analyzer never give as a token, which is the comment. Whenever parser will ask lexical, please give next token. Whenever lexical analyzer got to know it is a comment, he don't give. If he give, he will create tree for that also. Whatever lexical will give, to that he will create tree. So lexical don't give, right, comment line, parser don't create. So we done really good work. Today we really done good work. Tomorrow, listen, tomorrow as soon as we start the class, how to find out tokens I will explain. Tomorrow as soon as I will start the class, how to find out tokens I will explain. Tomorrow's class purpose is how to find out tokens. How many tokens are they? In tomorrow's class, we will clearly see how many tokens. Right? So the purpose of today's class is just I want to introduce. There is a linking of all these pages. You cannot say one by one. There is a linking. Is there. Yeah, can we go further? Can we stop it? Can we stop it? Yeah, those people who are preparing for GATE examination seriously, right? Those people can join this new batch. You can join. If you are serious about GATE examination, you can join in this batch. Go to ExamPrepTool.com. You can join 1-year course or 2-year course or crash course, whatever you want, you can join. Right? Thank you so much. See you in the next class. Tomorrow morning class or evening class? Evening. Tomorrow evening. Tomorrow evening class. No, after 5 classes, 2 more classes are there. 2 more classes are there. 2 more classes, total 5 classes. Fine. Chalo then.